It's reality. Scientists finally discover first ever white hole. Black holes are fascinating monsters. They shred stars and planets as massive as Jupiter, spinning wild enough to capture everything within their mysterious caverns. Once past their event horizons, nothing can escape. One even dwells at the center of our galaxy and possibly at the center of almost all the galaxies we harbored in the night sky. They are without a doubt one of the most powerful objects in the universe. And yet, as little as we know about them and as fascinating as they are, it's their counterparts that prove even more elusive and more exciting to consider. Today we're going to talk about the amazing discovery of white holes made by scientists. What exactly are white holes? Are they different from black holes? How did scientists happen upon them? Well, stick around till the end as we answer these questions and more. So let's dive right in. Not long after Einstein introduced the world to general relativity in the early 1900s, there emerged the foundation for black holes and their mathematical opposites, white holes. Einstein himself didn't predict them. He thought the extreme nature of black holes was far too outlandish to investigate. Yet to other scientists, they became big points of interest. White holes were long thought to be a figment of general relativity, born from the same equations as their collapsed star brethren, black holes. More recently, however, some theorists have been asking whether these twin vortices of space-time may be two sides of the same coin. To a spaceship crew watching from afar, a white hole looks exactly like a black hole. It has mass. It might spin. A ring of dust and gas could gather around the event horizon, the bubble boundary separating the object from the rest of the universe. But if they keep watching, the crew might witness an event impossible for a black hole, a belch. This opens up the possibility for the existence of white holes. At their very essence, black holes and white holes are composed of a singularity, where an immense amount of mass is condensed down into a small amount of space and an event horizon. They are identical to one another except for their direction of passage. While black holes devour matter and let nothing escape, white holes emit huge amounts of matter and energy, allowing nothing to travel inside them. They could never be entered. If an intrepid crew did attempt to enter a white hole, the sheer force of the gamma rays would destroy them and their ship. But even if the ship was strong enough to withstand that amount of energy, space-time around the white hole is structured so that the amount of acceleration required to get inside gets higher and higher the closer you get. In short, getting inside a white hole requires more energy than there exists in the entire universe. But just because a white hole obeys general relativity and is mathematically sound doesn't mean it's practical. Many scientists call white holes an impossible possibility, meaning that while they can't be completely ruled out, they also don't expect to see one in our telescopes. This is because this phenomenon violates the second law of thermodynamics. Entropy in the universe must always stay the same or increase. Entropy is often described as chaos, but can be better explained as an increase in how many states are possible for particles in a certain system. For example, a house demolished into rubble is an increase in entropy because that rubble can go on to make many other structures, sheds, bookshelves, mounds, and paper, whereas a house is only one very specific state of those particles. Small local decreases in entropy can occur as long as the universe's overall entropy is increasing. Black holes are excellent at this because they take matter low in entropy, such as planets, and disperse them across large spaces over time, increasing the chaos of space. White holes, with their outpours of matter, violate this law as they would decrease overall entropy. This is also why physicists argue that time cannot go backward. But this still doesn't make white holes impossible. A rare dip in entropy would temporarily reverse time and form a white hole. The only problem is that once time resumed its normal course, the white hole would explode and vanish in a powerful burst of energy. Some scientists speculate that this is exactly what created our universe. The Big Bang does mathematically look a lot like a white hole, the only difference being that the Big Bang had no singularity and instead occurred everywhere at the same time. But it would explain why so much matter and energy suddenly appeared. Some researchers have cited white holes as an answer to the black hole information paradox, a contradiction that says that information swallowed by a black hole is permanently lost during Hawking radiation, but that this would violate a law of quantum mechanics that says that no information can ever be destroyed. If a black hole was connected to a white hole, all matter and energy consumed by the black hole would emerge from the white hole either in a different part of the universe or in another universe altogether. This would solve the question of information conservation. Hawking supported this theory for many years. Similarly, in 2014, a team led by theoretical physicist Carlo Rovelli suggested that once black holes could no longer evaporate and shrink due to the constraints of space-time, the black hole would then experience a quantum bounce, i.e. an outward pressure, and transform into a white hole. This means that black holes become white holes almost at the instant they form. However, outside observers continue to see a black hole for billions of years because of gravity's time dilation. If this theory is correct, black holes that formed in the early years of the universe could be ready to die and burst into cosmic rays or another form of radiation at any moment. In fact, we might have already seen one. So are you guys enjoying this video? Do you really believe scientists have finally discovered a white hole that exists out there in the universe? How did they do it? We know the answer, but do you? So while you think, do subscribe to our channel and click on the bell icon to receive instant notification about all our future videos. On a balmy summer day in 2006, NASA's Swift satellite captured an exceptionally powerful gamma ray burst called GRB 060614 in a very strange region of the sky. Whereas these kinds of bursts fall into one of two categories, short burst and long burst, they're usually associated with a supernova. GRB 060614 didn't do either. It lasted for a remarkable 102 seconds, but wasn't associated with any star explosion. Most gamma ray bursts, for comparison, last only 2 to 30 seconds. GRB 060614 took place in a galaxy that had very few stars able to produce explosions or long bursts. It appears to astronomers and astrophysicists that this gamma ray burst came from nowhere and simply collapsed in on itself after just a few short moments. A few years later, scientists introduced the hypothesis that GRB 060614 could have been a white hole. This does, after all, describe perfectly what we would expect to see from a white hole: a powerful, unstable fountain of matter and energy that disappears shortly after forming, usually from a point too small to see. And while it can't be concluded that GRB 060614 was in fact such a fantastic phenomenon, current scientific models have no explanation for what happened. NASA scientists do believe something entirely new was responsible for the gamma ray burst, and many admitted that despite dedicating a great deal of time to observation and data, they simply don't know what could have caused it. Since its discovery in 2006, dozens of telescopes, including Hubble, have studied the event. For now, no one can say with certainty that we've seen these fantastic objects in our universe, but we can say this: general relativity breaks down at a black hole's singularity. Energy density and curvature simply don't allow general relativity to be a good descriptor of what happens inside a black hole. It isn't until we have a more complete understanding of physics that we can rule out objects like white holes and wormholes, which live, for now, only in our science fiction. But I suppose it's important to add that at one point, black holes were considered fiction too. So do you think white holes exist out there in the universe? Or is it just a theory that'll forever remain part of science fiction and never become a reality? Let us know in the comments below. And if you want to watch more of our amazing videos, then stay tuned.